Hey, welcome. Today, we are going to pull back the curtain on the technology you use literally every single day, the modern computer. We're going to go on a journey from your fingertips on the keyboard right into the heart of the machine and then all the way out into the cloud. Let's do this. I mean, we all use these things constantly, but what is actually going on under the hood? It can feel like some kind of magic, right? But it's actually a surprisingly logical system. And that's what we're going to do. We're going to peel back all those layers and see exactly how it all fits together. So here's our game plan. We'll kick things off with the single most important part of any computer system, which is you and your place in this digital world. Then we'll dive straight into the machine itself, software, hardware, all the core parts, and how you talk to them. And finally, we'll zoom way out to see how your computer connects to, well, everything through the web and the cloud. Okay, first things first. Before we get into all the circuits and the code, it is absolutely crucial to remember that technology, at its core, is all about people. It's about you, it's about me, it's about us. See, a computer isn't just a box sitting on your desk. It's just one piece of a much larger information system. And right at the center of that whole system, the most important part is people. We're the ones who give it all a purpose. Everything else, the software, the hardware, the data, even the internet itself, they're all just tools designed to serve our needs. Now let's break the computer itself down into its two fundamental halves. You've got the software, which is all the instructions, and you've got the physical hardware that actually does all the work. This is the big idea, right here. The easiest way to think about it is this. Your computer is your own personal office. The hardware? That's the physical stuff. The room, the desk, the filing cabinets. And the software? Well, that's your to-do list, your projects, all the instructions for the tasks you need to get done in that office. Now, software itself is kind of split into two types. First, you have system software. In our office analogy, this is like the building's hidden infrastructure, the electricity in the walls, the plumbing. You don't actively think about your operating system, but without it, absolutely nothing works. And then you have application software. These are the tools you actually use day to day to get stuff done. Your word processor, your web browser. They're like the pens, the paper, and the calculator sitting on your desk, all built on top of that basic system. All right, now we're going to metaphorically open up the case. Let's take a look at the actual hardware components inside that are doing all the heavy lifting, the real core of your office. So meet the brains of the whole operation, the CPU, or the microprocessor. If the computer is your office, the CPU is basically you, or, well, at least a brain. It's the part that does all the active thinking, the calculating, and the processing. It's the engine that makes everything go. Okay, so if the CPU is your brain, what's RAM? Think of it as your desk. RAM is the temporary workspace that holds all the documents and programs that you are actively working on right now. But here's the catch. The key word is volatile. Just like how you clear off your desk at the end of the day, RAM gets wiped completely clean every single time you turn off the computer. And that brings us to the filing cabinet. If RAM is your temporary desk, your hard drive, that's your permanent storage. It's non-volatile, which is just a fancy way of saying your files are kept there for the long haul. They'll still be there when you turn the computer back on. It's a bit slower to get things from the filing cabinet than from your desk, but it's where everything is stored safely and permanently. So, we've seen the brains and the workspace inside the box. But how do we, the users, actually interact with all that stuff? Well, that's where input and output devices come into play. Think of input as a one-way street. It goes from you to the machine. Your keyboard, your mouse, your microphone, they're all just translators, really. They take your physical actions and convert them into digital signals that the CPU can actually understand and work with. And you guessed it, output is the street coming right back at you. After the CPU has done all its work, output devices, like your monitor, translate that processed information back into a form that we can understand, as images or text or sound. A monitor gives you what's called a soft copy, which is temporary, while a printer gives you a hard copy you can actually hold in your hands. So that's one computer. But the real power, the real magic, happens when we connect it to billions of others. So let's talk about the network that completely changed the world. This is a really common mix-up, but the internet and the World Wide Web are not the same thing. Not at all. The internet, the actual physical network of wires and computers, was launched way back in 1969 as a government project. The web, the graphical, clicky thing we use every day, that didn't even show up until 1991. Let's go back to our office analogy. The internet is the physical infrastructure. Think of it as the mailroom and all the roads connecting different buildings. The web is just one of the services that uses that infrastructure. It's like the letters and packages being sent through the mailroom. So things like email and file sharing also use the internet, but they aren't the web. In short, the internet is the hardware, and the web is just one type of software that runs on it. And that brings us right into the modern era. Because these days, the whole idea of computing has shifted. It's not just a local thing happening on your machine anymore. It's a global activity, happening on massive servers somewhere else entirely. So what is the cloud? Honestly, the simplest way to think about it is that you're just using someone else's computer. Instead of storing your photos on your own hard drive or running programs on your own CPU, you're basically renting space on the massive hard drives and powerful CPUs owned by companies like Google or Amazon or Microsoft. You're outsourcing your digital office work to a giant warehouse. And this is pretty much how it works. It really breaks down into three essential parts. First, there's you, the client. Second, there's the internet, which is the pipe connecting everything. And third, you've got the service providers. Those are the companies that own and operate those massive data centers, those digital warehouses that store all the data and run all the software for us. And there you have it, from a single key press all the way out to a global network. We've gone from computers that filled entire rooms to devices in our pockets that have exponentially more power. I mean, just think about this. The computer that guided the Apollo 11 mission to the moon had less processing power than the smartphone you probably have in your pocket right now. It's incredible, and it really makes you wonder, as this technology gets even smaller, even faster, and more connected, what on earth will our computers let us do next?